Well, so basically, in homework one, last week we were talking about this bouncing ball. Um, so what you will do is just, whenever you hit the walls, you want to, um, you want to bounce it back. So you swap the speed. Now the speed will become negative, so that it will, just um change the direction. That's basically it. So you initialize the bow, position it in the middle of the screen, and then you just keep moving it with this. So you just x plus equal speed x. That's a shortcut. So this thing is just a shorthand for x equal x plus speed x. Um, so the whole algorithm thing, the whole programming thing is just that people are lazy. So, even with x equal to x plus speed x, people don't want to write that long. So now people do x plus equal speed x. So this basically just, move the x position by speed x. And you can set the speed x into, the speed of the ball. So, you just determine how many pixels you go by each frame. That would sort of determine the speed of the ball. So in homework one, you basically just do it, but now you are moving a text box rather than a ball. So the tricky part is to sort of figure it out through the documentation, but I guess mostly from the instruction, you will likely get all the functions you need, but you just need to go into the documentation to get yourself familiar with how to read or access the documentation, so that you can find the size of the text rendering. And then you want to turn it into, um, two-dimensional. So now you have X and Y rather than just bouncing in the X-axis. So that's basically homework one. I hope it's not too tricky. It's very specific in the instruction because I want you to be specific all the thing we've go on. So try to follow that. And in future assignments, you are free to just make it whatever color or whatever shape you like. Be creative. But for this assignment, I hope you can just follow all the instruction and try to, go through this process that you have something in your mind and know about how you can implement that to realize the specs, the specification that you have. And for saving in animation, likely we can go over this and you can try it now because you will need it for your assignment. So you go to processing. Have you installed this? I think we just rushed through this last week. My processing is starting up. Let me see. Okay, cool. So go to tools, go to manage tools, show it here. And under the tools tab, you will see this movie maker 2. And you click install, then you get it installed. So once you install it, you can find the movie maker here. So still in the tools navigation bar. You find this movie maker, and then you will have everything here. So basically, you want to save all the frames after you draw something. So this is included in the template already. Let's go check it out. we can find the template code here. So you see that there's this things. If save frames, you will save all the frames to this frames directory, and there will be three things. This will basically just rename these files to 000.png, 001.png, all the way to whatever, 999.png. So this will just create a bunch of PNG files. And you need to set the save frames to true so that it will start saving it. So it would be nice because once you are done with your homework, then you just turn it into true to save all the frames. So now you will have all the frames in that frame directory. So now you go to the movie maker thing. So basically now you choose that frames directly here. And then you set the frame rate to 30. So GIF has, unfortunately, the maximum frame rate you can use for GIF is 30. So you have to set it to 30. And then you just choose where to save it. Then you will get the GIF. So that's also why we need frame rate to 30 FPS here, because for GIF saving. Otherwise, you can use whatever frame rate you like. Cool. I guess that's it. So you will need this in assignment. Just let me know if it doesn't work. For Windows user, there's a bug. So you have to do exactly this. You just need to download the FFmpeg file, and then you have to, you will get this, and once you save it, you extract it, and then you want to copy this to this specific folder, so that now it knows where FFmpeg is. So the bug is that it actually download macOS executable to a Windows machine, and the Windows machine just doesn't work. So that's an unfortunate thing. But anyway, it could be fixed this way. Questions on homework 1? I saw there are 2 submissions, so some folks have already started doing it. Anyway, just let me know if there's any questions. Cool. So just a quick recap what we've talked about last week. So we talked about the setup and draw. So in processing, we always start with these 2. So you set up. So typically you will set up the size of the canvas, and then in draw function it will be code or round every frame. So this is the difference. So if you put the background here, everything will be flash out every single frame. But if you move the background to the setup, now you set the background to 50, so this grayish background, and now you do the draw, but you didn't clear a background again. So everything will be left on the canvas. So that would be nice if you want to do, trays, or, to do a very interesting, iterative, or to show how you get your final generative art. And we talk about mouse function, mouse drag, mouse click. There's a bunch of them, but basically these things just sort of like draw. So see that draw function has nothing here. So for every frame, do nothing. But once you have mouse drag, mouse click event, these things will be executed. So that offers you a very easy way to build something that's interactive. Questions? Nope. No worries. Yeah, and we look at this, the creepy eyes. So, it's just a bunch of math. Likely still remember what we are doing. But basically, you have your mouse X, mouse Y position, and you want to sort of like move the original eye toward your mouse X, mouse Y direction for a little bit. So that's like 10% of displacement. So that's all the math is about. You have mouse X, you have the original eye position, and you want to figure out where they are, but now you times 0.1, which is same for divided by 10, then you get the slightly deviated eyes from the original one that follows your mouse position. And then we go to this never stopping ball. So this is when you just move the ball all the way to the right without doing any, wall collision check. So you would just go through it. So the ball is still running. After you run this, just the ball is outside the canvas. You couldn't see it, but the ball is still running until infinity. But the bouncing ball is that, you want to do some if else. So this is the syntax if, and then you have the parenthesis to say, what are the criteria. And if the criteria is true, then you do this. Otherwise, you do this. But this is else if, where you combine two if function together. Cool. And then homework one. So today we will be talking about keyboard controls. It's a little bit more trickier than mouse, because now you want to see what's being typed. And we'll also talk about randomness to make some fun. Cool. Let me grab the new slides. Cool. So just like we have like mouse click, mouse pressed, mouse dragged, mouse moved. For keyboard, we have like keyboard pressed, keyboard key released, key typed. So it's a little bit confusing, but press and release is that you click it, you click it, you press it and you release it, then it consider, in mouse case it's like clicked, but for key it's like typed. So basically the same idea, the downward action and the upward action is considered two different actions, and combining them together is the typed action. So guess what this does? Should be very straightforward. When which key? Yeah, exactly. So that's how the whole key thinks this. So you basically just check for which key you are pressing. So this works for most of the keys you can see on the keyboard. So it's also for the space. So most of them you can do it this way. Either press or release, you will be able to do this. So this key, this is a variable that will automatically be assigned to whatever key that's being active. And by being active, it means that release, press and release both are will trigger the system to save that to this key variable. So that works for a lot of things, but things will be a little bit different when you want to do the keyboard control, like up, down, and left and right. So that's when you need this key equal coded. So up, right, left, and right is very tricky because it's not just you cannot do key equal something to do that. So now you need to first check whether this key is coded. So coded meaning that those are special keys. So for all the special keys, you need to first check whether the key is coded, and then you do, key code equal out. So there will be a bunch of, well, I don't think this should be here. So there will be a bunch of special keys that will be up, down, left, right, the arrow keys, but also Alt, Control, and Shift. That will be special keys. Then in this case, you need key code rather than just a key. So you cannot do something like, key equal, I don't know, something like Control. This doesn't work. You need to first do, key equal to coded, and then key code equal to Control. Yeah. To detect whether Control key is being pressed. So it's a little bit confusing because backspace, tab, enter, return, escape, and delete. Now you don't need key code, so you can actually just do key equal these things. So it's a little bit confusing, but there's some fundamental limitation on keyboard interaction because everything is based on Java. And some of these keys are processing differently in Java. But basically, if you want to do up, down, left, and right, this is the way to do it. So there's also this thing that we didn't really dig into last week. This is the AND operator. So you see that this is when you see, if key equal to coded, and then you want to, sort of like put another block of if statement here, but it will take out a lot of space. So there's another way to do it is that you can put this AND operator. So this AND operator is that both, it will be only executed when both these are true. So this could be handy to make your code even neater, so that you don't need to have a bunch of, too many parentheses. So once you do that, this will be AND, and for OR would be 2 vertical bars. It's just the convention in Java. Cool. So these will be key and key code. That's pretty much all we need. So this is what I mean. By backspace, you don't need to use key code. This is very confusing, and there's no way you can remember it. Just you just need to do this. So you just directly check for key equal backspace rather than using this as you are doing it with arrow keys. No simple way to remember that. I guess you just need to make sure that only these 7 keys you need key code. Everything else you have special variable that you can check directly. Cool. So I guess we can do a quick exercise now to build this program where you can use your arrow keys to control a goal. Shouldn't be too tricky. You just need a bunch of if else, but to get familiar with key and key code here. Cool. So think about what variables do we need? And you will need key code for all these. So it should start it in the middle of the canvas. So what do you need as a variable to store where it is? Cool. Let's do it together, I guess. So what we need, we at least, I think the only 2 variable we need is the X and Y position. So we at least need 2 integer or float, whatever. And we can already initialize here because it will start it in the beginning. So now you just write the setup thing and then the draw thing. Oops. So for the setup, we just set up the canvas, nothing else to be done. For the draw, I guess we will clear it every time, every frame, clear everything, and then we will just draw this circle for at the XY position for diameter 10. So now the tricky part is to detect keyboard actions. So now you have this key press event. Whenever the key press, you want to change the position of the ball. So now, if key equal coded lowercase. So lowercase is usually for a variable, but uppercase is global variable. That's already predefined. Usually that's the convention. So if key equal coded, now you check whether the key code is up. Let's do left and right first. So if the key code is left, then you want to, move the ball, 10 points, pixel away from the to the left. So now you want it to be x equal x minus 10. So that will basically do the trick that you will move the things to left for 10. Now you just basically copy everything. Now you want to do right. And now you want to make it a plus sign rather than that. So this should give it us something that should be working for the XY, for the X movement, the horizontal movement. So now you should get something like this. And now you can press the left and right key. So now it will just move around. And if you hold it, it will actually just go out of the canvas, but you can still bring it back. So, basically the same. You can apply, use it for up and down. So when you do up, you want to have y equal y plus or minus. So this is the tricky part here, because the canvas is pointing downward, the axis. So you want to do minus when you want to go up. Cool. That's it. So now you can control it using your keyboard. Everyone done? Cool. So just to get yourself familiar with, these things, it could be very confusing because some of the article, if you want to use WSAD, then it will be much easier. You just use this, key equal to W, and you don't even need the key code thing. But for arrow keys, you need to first check whether it's coded, and then you check for the key code. Cool. So that's the first easy exercise. Now you can at least use the arrow keys to control it. Now you can do some fun games, I guess. So that's it. Left, right, up and down. I think the most tricky part is the up. You want to minus the y if you want to go up, because the error for the axis for y axis is points downward. Cool. I think we just use this. We just show it in the homework one example. But anyway, there's also this if statement. So we talk about if and then else, but you can actually just combine them together. Now you have this else if. So to be more precise, what's going on? This is equivalent to this. So you have an if statement, and now everything you want to embed another if else statement inside the else statement. So you can actually just write it as a shorthand. So you would do the first condition. If this happened, I do something. Otherwise, if this happened, then we do these things. And finally, if these two doesn't happen, then everything else, otherwise I will do something else. So this is a way to have multiple condition check. Condition one, you go to this. Condition two, you go to this. Everything else, you go to this. So that's a much handy way to write instead of this. Cool. Yeah, you see that it's just basically just embed an if-else statement into a bigger chunk. So you can actually also rewrite what we have here into make it much cleaner. That's not the case. So you can, move the if statement here. So if else versus if. So if you look at the left-hand side and the right-hand side, it's slightly different. So at the left, it's like if mouse X larger than 300, then we fill with 0. So it will be, first it will be, everything will be the 0 color. So 0 is the row is black, right? Yeah, 0 is black. And so now if we want to do if mouse x smaller than 100, so now these will be the y1 because it's 255. And everything else, you will fill it with 127. So now you get everything else become gray. So this thing is no longer relevant because everything here is impeded by this if else statement. But for this things is doing two condition check. If mouse x is larger than 300, then it will be black. If mouse x is smaller than 100, it will be white. Everything in between will be 127. So, sometimes you need to be careful about if and else. So the thing is that I do this check and I fill with 0, but it's no longer relevant because now you have this other check. Everything will either fall into mouse x smaller than 100 or mouse x larger than 100. So this thing is gone. But if you are doing the right-hand side one, it's actually doing two condition check and then everything else. So it's slightly different. So these two else has different meaning. So for this else, it will be mouse x, no smaller than 100. But for this else, it's a different thing. It's in between 100 and 300. It depends all on how you write the if else statement. So you have to be careful about this. So, to make it even another way, you can also use this switch statement. So it's basically, sometimes you are doing this if else too frequently. People sometimes don't like it. So I code in Python and Python doesn't have switch statement. So I actually prefer just using a bunch of if. I think the new version of Python now have match expression, but still people are more if else like. But anyway, this is the way how you write a switch statement. So basically, switch statement is that you will have an expression, say mouse x, and then you just check like what's the value of those things, and you can do different things. So this is basically equivalent to if else. So you can turn this into a switch statement basically. I think I won't go into that. We can just look at what it does. So in the middle part, we are doing a bunch of check. If key code equal to left, if key code equal to right, if key code equal to up, if key code equal to down. You are just doing a lot of like if else if else if else if. It's kind of not elegant enough. Then you can do the switch statement where you just switch the key code thing. So this will be the thing that you are checking. So if key code equal to left, so that's basically doing the first check. Then you do x equal x minus step. The downside of switch is that you always need to break it here. And now if that's not the case, if the case is that key code equal to right, the second condition, then you do this. And the same apply to other things. So this is just another way to write a bunch of if else to make it more elegant. And there's also ways to combining multiple conditions in switch. Basically, you just have a bunch of case together, right after another, just stack them together, and then you do the same thing for all these case, but remember to break it. So not until you have this break things, you will get out of the switch block. Anyway, to be honest, you don't really need switch unless you have a specific reason for that. But for most of the case, if else would just help you go over everything. Cool. Questions? Nope. Okay, cool. Let's do something fun. So now we are jumping into a totally different topic. That's randomness, but that's also very fun because you can do a lot of things with just randomness, random number generator. So for random number, the basic functions are just random, random high, random low high, random Gaussian. We will go over it later. So for random high and low high is that you basically just generate a random number between this range. So if you don't specify the lower and then it will by default set to 0. So if you do random 1, this is equivalent to random 0, 1. That's it. So you can do it that way. But anyway, this will generate a uniform distribution. By uniform, it means that every single number will be equally possible to be generated. But sometimes you don't want that. Sometimes you want something that's more concentrated. So this is the Gaussian number, the Gaussian noise. So basically, we'll generate a more natural things that center around the mean of your distribution. So random Gaussian will always give you that 0 mean and Gaussian with the standard deviation of 1. We will go into what it actually means later. But basically what you can do now is to do some random generation. So, the most simple thing we can do, let's get rid of all this key press thing. The most simple thing we can do is that, well, we have X and Y. And we set Y equal to 0 to get started. And then we get rid of this. Okay, so what we can do is that for every single frame, we will just do X equal to random 0 to 400. Or we can use width to be easier. So because we set the size to 400, 400, so now you can do width here. So this has the benefit rather than, hard-coded 400 is that, whenever you change the size, it will just automatically scale to that. So you don't need to, rewrite it. Oh, we need a float rather than integer. Cool. So, and we want to just go, the Y will become increment by 1 every single step. Yeah, that's the simplest random things we can do. So what's going on here is that for every single step, we will just increase Y by 1, and then we will just randomly select a X value between 0 to width. So that's why you see, every single step, you just keep moving downwards, but you will randomly choose a random number to draw your X position. So that's the most simplest thing we can do with a random number generator. So you can see that it's uniformly distributed. So every single value is equally likely to be sampled with this random number generator. You can also set the range. So, as I said, if you don't set the upper bound, lower bound, it will be 0 to width. So this is the same as this. It will be 0 to width, but you can also say something like 100 to 300 so that it will be constrained within this region. Or I don't know, 180 to 220. Cool. And so now we are doing some, fancy animation, but you can also imagine that you could just use this to generate some, interesting patterns. So for Gaussian, it's a little bit trickier. But anyway, I don't think we necessarily need to understand what Gaussian is. I guess this is more than enough. You just need to remember 68, 95, 99.7. To be honest, I don't even know what the Gaussian distribution is. There's a formula, but I never remember it. But all I remember is just this, like 60%, 68% of data will be within the 1 sigma. So the 1 sigma is the standard deviation. And over the time, you might see this again and again somewhere. So 95% is when we say something like significant test. If you talk to someone in, in medicine or in biology, then they will always talk about, significance test, and they will talk about, well, do we need 2 sigma or 3 sigma or, 5% confidence interval? That's whenever people are talking about this number. So what's the chance that this is a very unlikely event or this is a very significant event to happen? So basically 68% will be in the 1 sigma range. So 0 plus 1 standard deviation minus standard deviation, 2 standard deviations, 3 standard deviation range. So 99.7% of data will be in 3 sigma range. Anyway, that's just some numbers for you to get a sense of what Gaussian is, but I think the easiest way is to just do it. Gaussian. So one thing about Gaussian that's a bit confusing is that Gaussian will not take any parameters. It will always generate something that's 0 mean and with standard deviation 1. So you have to scale it yourself. So now we can time 50 so that let's just do it this way, I guess. So if I run it, it will basically everything will be at the left-hand side because it's generating something too small that it doesn't you couldn't see the spread of it. So now we can move it by 200. Now let's move it to the center of the thing. So you add 200. Now you can see that it's being in the middle, and there's some tiny fluctuation because now the spread is not enough. The standard deviation is 1, and as I said, 99.7% of data will be within 3 sigma. So that's only 3. So what if we times it by 10, for example, then it will spread out more in the, plus minus 30-ish or 20-ish. Now, if you do 50, then it will be even more spread out. So this is the way how you control a Gaussian distribution. So now you can see that Gaussian distribution is no longer uniformly distributed. It will be more concentrated in the mean. So that's what Gaussian is. And for Gaussian, there's no way you can provide the mean and standard deviation. So you just do this and then you scale it yourself. So once you do random Gaussian times 50, now you set the standard deviation to 50 so that the spread would be 50 to something bigger. And it will center at 200 because everything you get from this, it will be center around 0. So you add 200, so that is center around 200. So anyway, I don't think you necessarily need to get what Gaussian is doing, but I guess this is always a nice numbers to remember: 68, 95, and 99.7 rule. So in this case, random Gaussian, now you set the standard deviation to 50. So you can see that 68% of points will be in the middle part. That's the 1 standard deviation range, 1 sigma. And then 95% of that will be in the middle part. So if you count, because we have like 400 points here, because y is 400. So 400 times 5% would be 20. So if you count where the outside balls would be 20-ish. Cool. And 99.7% will be in this range. And you couldn't see it because everything outside the range, you couldn't see it. But anyway, you can also set it to a smaller spread, say 10. Then now 68% of numbers will be within the 1 sigma range. That's like plus minus 10 and 95% will be plus minus 20, and 99.7% will be in plus minus 3%. So that's a really good rule that you can remember, could be handy from time to time. Cool. So that's the two random function that we have. So now what we want to do is this. Random points in the circle. This is a little bit tricky, but over the time you might want to use this, especially when you are designing some cool art. So how do we randomly sample a point in a circle? So this is the first strategy. We just sample randomly and we just keep only those fall into the circle. So let's do it. So you want it to be uniformly distributed. So you likely want to use random, 0, 1 or 0 to 400. And you want to do it for X and Y, both. You want to get a random X position, but you also want to get a random Y position. Well, we'll just work on it. Oh, good. You're done? Nice. Yeah, so first thing, you wanna do randomly sample something. Just forget about the circle. Just get something like this. Oh, it was something like this after, I don't know, a minute or so. So you just want to get random sample across the whole thing. So how do you get that? You just want a random X, a random Y, and then you draw it. Cool. Are you done with the random thing? Cool. Shouldn't be too tricky. So this is what we can do. Basically, you just need to set up like a flow X and flow Y. And then you will set the background once, and you don't want to clear everything before. So for every single frame, you just want to get a random number X within the range of 0 to width, and a Y in range of 0 to height. And then you just draw it. So that's what you get. So now the tricky part is that we only want those points within the circle. How do you do that? You want to do an if else to compute how far away the bow is from the center, 200, 200. And you only want to keep it when it falls into that radius. So what you want is something like this. You won't get these points. Square? Yeah. You mean how to get a square number? Yeah, like 2 squared. You just times it. You just times it. So that's the thing we talked about this last time, because it's so ugly to write it that way. You can actually just use this distance. X, Y, 200. Oh, 100. This thing would just calculate this square root x minus 200 square plus y minus 200 square. So that you don't need to write everything there. But yeah. This is topography. Anyway, what one is this? Successful? Kind of. So, this distance can help, but if you want to write it out, what you will get is likely something ugly like SQRT, that's the square root, and then you will have x minus 200 times x minus 200 plus y minus 200 times y minus 200. And then you get the distance. So this is much more elegant. There's also the power, I think it's POW, to get the square, I think. Yeah, you can also do power. You can also x minus 202. This will give you x minus 200 squared. But anyway, distance should be the way to go. Cool. Are we good? Cool. So what you can do, like the ugly way to do it is just something like this, where you can just check for the distance from 200. So you can write something ugly like this, square root x minus 200 times x minus 200, y minus 200 times y minus 200 square root, and it should be less than 200. So your distance to the center should be less than 200. That's the definition of that circle, right? But to make it more elegant, you can also just use distance. So x1, y1. So this is the first point, and the second point would be 200, 200. So if the distance from the xy point, like your current circle, to the center, 200, 200, is less than 200, then we draw it. Otherwise, we don't draw it. So this should just give you that things that we want. Cool. Oh, good. Questions? Do you like it? What's the downside of doing this? Exactly. And this is because our, the circle sort of like, because, this is like 4. The square is like 4, but this is like 3.14. So you're losing like 25% of frames. But imagine in other case where maybe you are drawing like stars, then you will have, a lot of frames that's not doing anything. So this technique is called rejection sampling, which is very simple. You just do whatever you want, and then you check for the boundary. And if the boundary condition works, then you draw it. And if not, you just skip that frame. So this has the benefits of like, things are very easy, but it could be very, unpredictable on the frames, especially when your condition is very strict. So anyway, we just talk about this. So the second strategy is to do it in polar coordinate so that you get everything in every single frame. So that's what we will go on in the next few slides. So before that, I guess we would just talk about what's polar coordinate. So this will become very useful, especially when you are think about, doing some orbit, think about doing anything circular or rotating stuff. You sometimes want to do polar coordinate. So polar coordinate is different from the XY axis things that we are using typically. So polar coordinate look like this. There's just a bunch of circles and there's just one single axis. There's no two axes, just one single axis. So how do you define a point? Is that how far away you are from the origin and what's the angle, what's the offset of that angle from the axis, the only single pointing axis. So to define a polar coordinate, you need an origin and an axis point somewhere. And then to define a point on the polar coordinate, you do r theta. So r is the radius, so how far away you are from the origin, and theta is what's the angle between you and the thing, the axis. And in polar coordinate, the tradition is that the angle will go by counterclockwise. So this will be 0, this will be 90 degree, this will be 180 degree, this will be 270 degree. And then again, now back to 360 degree, you will back to the same point. But again, processing is different. So processing work on the other side because the y-axis is fixed, flipped. So in processing, it's actually doing the other way. So this will be 0 degree, this will be 90 degree, this will be 180 degree, this will be 270 degree. Yeah, we have it. So this is polar coordinate, not in processing, it's in the typical way, but in processing it's fixed. But more confusing is that typically we won't even refer to this 180 degree as 180 degree. Usually we refer it to pi. So that's one of the confusing thing about it, but normally you won't even notice that. What you want to know is that go from 0 to pi, then you get the lower half circle, and you go from pi to 2 pi, you get the upper circle. We will get into that later. You will see more examples. But these are like two different examples. Say this one is r theta, but you can also move it toward this point. Then your theta will be larger than 180 degree. It will be 235 degree. Cool. So this point will be 4 pi over 4 pi, so 1.25 pi-ish. So 4 because your radius is 4, so you are 4 steps away from the origin, and the theta is more than pi. Yeah. There's no reason, just definition. But you sort of want to get familiar with it. We will use it in homework too. So how do you turn polar to Cartesian conversion? Even though the math would involve some sine, cosine, but to be honest, that's it. And most of the time you just code the function without calculating it by hand. But basically you will get this thing about for sine and for the horizontal one for cosine. And there's I don't think there's any easy way to remember that. I think the easiest way I remember that is that, when you write a S, you write it this way. So this will be the sine. And when you write a cosine, you write a C. So this will be the cosine. That's how I remember it. I sometimes still forgot which one is cosine, which one is sine. But anyway, that's how you convert polar, like how far away it is, what's the angle of the 0-degree line. But how do you convert that into something you can plot on your canvas? Then you want to do R cosine theta and R sine theta. So for processing, you just whatever, just do R times sine theta. So very straightforward, all the math, but turns out for programming, you don't need to do anything to just write it that way. So you need to remember is to just this R cosine theta and R sine theta is how you get the X and Y position. Question on this? Nope. Cool. So in this example, you will just realize things will be much easier if you're doing stuff in polar coordinate. So what you can do now is that we no longer want to do X and Y. Now we want to do R and theta. So theta is the convention of angle. You can also do angle, but I think angle is predefined. So R will be the radius, how far away you are. Theta will be the direction. And we are starting from the middle, 200, 200. So now let me get rid of these. So what you want to get is like the radius. It will be a random number between 0 and 200, right? Because you started in the middle. You want a radius that's lower than 200. You want something that's no further than 200 pixels away. And you want to get a theta. That's the direction. You want to randomly select a direction to shoot that ball to. So you also get a random number. And now this is the tricky part. You want to do, 0 to 360 degree. But again, in processing, we don't do stuff in the typical degree. We do stuff in pi. So what we want here is 2 pi. So 2 pi is a predefined number. So 2 pi basically is 360 degree. And in processing, it's coded as 2 pi. That's it. So now you get the R and theta. So now you want to turn it back to X and Y. So now you realize now we need 2 more variable. X and Y both are float because these could, these are not integers anymore. R times cosine theta. Oops. And then Y equal to R times sine theta. And forgot to draw it. So draw the circle at X, Y, with a radius 10. Hey. So, it was center at the origin. So we need to add 200 to that to move it to the center. That should be it. Cool. That's it. So now you can get samples in the polar system. What's going on is that you get a radius randomly, and then you get a random direction. So it will be sort of like shooting around that circle. Is this what we want? What's the problem with this? Yep. Why is that?
Or I guess with the all lines and outwards. Like the distribution lines outwards according to the further popular.
Yeah. Basically, that's the idea. So, we sample these two things separately. So, smaller radius are equally possible to be sampled as, larger radius. But for larger radius, you have more area to cover. So they will be more sparse. But for the center part, easily you will get the chance that it's in the middle part, but that just cover a very small range. So it will be much more dense. So I think I have a slide for that to have a better visualization. So this is a naive approach that I call this as naive approach because there's no real things because it doesn't work. So this is like you see that it's more concentrated in the center and sparse at the corners. So the reason why that is the case is that, when you do the sampling, the possibility of you get this range of radius is the same as the probability you get this range of radius because you are sampling the radius uniform. So you get equal chance to get this numbers from 0 to 130-ish, and this, to, I don't know, something to something, but they have equal length, so they have the same chance. But now, when you are shooting the theta, now you want to get the theta, you get the equally likely in this shape and this shape. So it will be denser in the middle and, much more sparse in the outside part. So these two area, basically, they're equally likely to get a point. And if you count over time, you will see that their numbers sort of like match to one another. And that's why the reason it's more concentrated in the middle. So how to fix it? Unfortunately, there is no easy way. And the trick is that you just add the square root here and somehow it works. So what we want is that now we are doing rather than just r equal random 0 to 200, now we do it the other way. So we will turn it into a square root of random 0 to 1, and then we times it by 200. So we sort of like redo this distribution of uniformity. So we want it to be less frequent to sample in the middle, more frequently sample at the opposites. And the reason why it's square root is just because some calculus things that you can calculate. But for this particular case, you basically can just do this and you will get it. And if you go on Wikipedia, there's a page for this whole thing called inversion transform sampling. There's no easy way. You have to do some math to figure out what's the exact sampling algorithm. But for this most simplest case for a circle, you just add the square root here, then you will get it. Cool. So at least now, hopefully, you're convinced that this turned the whole thing back to uniform distribution. So this thing will turn this, I guess I can go a little bit deeper into the math of that. So originally, when we do nothing, so this is the naive case, where we have this distribution is going from 0 to 1. They all have the same probability to get sample. But now we want to apply a square root on that. So square root function looks something like this. So it will get from 0 to 1, and it will go up like this. So you'll get this distribution. So now it's less likely, it's almost 0% chance, less likely to get smaller r. And that's exactly what we want. We don't want it to be a lot of chance to get in the center. The center is lower frequency. But we want to get more chance to get higher chance to get larger r. So the whole, inversion transform sampling is about how you just like change this distribution so that it matches the exact sampling algorithm that you need. Anyway, for most of the case, we are still doing rejection sampling because that's much easier. And most of the time, we don't really care about the whole, things about, well, we will randomly drop a frames, or sometimes you could just like, well, we just do more computation for this particular frames. And nowadays, our laptop, even our laptops can be very computationally powerful. So people don't really care. So for the naive approach, that's, we are doing polar coordination. If you don't do something, it will be denser near the center. And the rejection sampling, very easy. You just sample everything, and then you hope it will be in this circle. If not, you just drop it. So sometimes, you will lose a frame if there's another sample. Inversion transform sampling, you could basically apply a square root or some function. You have to calculate math or look up YouTube, not YouTube, I mean look up on Wikipedia. There's a page called inversion transform sampling. You will find all those formula. Require some math. It's also sometimes those formula cannot be tractable. You cannot find it in any case. But if you can do that, then you can sort of like get rid of both disadvantage here. Cool. Questions? Why so complicated, I guess? I guess there's no reason. If you want to do this, this is the way how it works. There's just no easy way to do uniform sampling within a circle. I think the most elegant one is the inverse transform sampling, but it only works for circles. For star shapes, then you have to do some other math calculation. Cool. Let's just move on. I think we got a little bit more time. This might happen at some point, but likely not in this class. So if you want to control the randomness, I guess this is also nice if you want to get a sense how your laptop or your machine generate these random numbers. So there's a case, especially when you are doing experiments, likely not in the case of creative coding, but if you are doing some other, experiments that you want to control that every time you want to get the exact same random numbers, it's actually possible. The truth is that these random numbers are not truly random. It's just random enough for most use case. We call these algorithms like pseudo-random algorithms. So what's happening is that these pseudo algorithm is sort of like there's a underlying list of random numbers on your machine that will always be drawing from different starting points. So you can actually set the random seed that will sort of like link you to a specific starting point, and everything beyond that will be determined. So you can actually control the random number generator to generate the same sequence whenever you set that random seed. So this can be done by using random seed. And put the seed number here. And this seed can be any integer. So 0, 1,000, 10, 24, whatever. But that's a way you can control the randomness. So could be helpful in some case, but most likely in this class, we won't use it. Cool. This will be homework too, but I guess we don't need to worry about it for now. I will send the instruction. It will be due 2 weeks later. And as you can see, it's pretty similar to what we are doing in homework 1. Just that now you have a paddle here. Now the bottom wall is different. If you hit the wall, it will be game over. But if you use the paddle, then it will bounce back. So you just need a different criteria. You need to know where your paddle is. So the paddle will be your mouse X, mouse Y, just mouse X. So this will be controlled by the mouse. I can show you how it works. But anyway, that's what you need. And the only difference from homework 1 is that whenever the game restarts, you need to shoot the ball at the random direction. And that's where you need the polar coordinate thing that we talk about in this class. Other than that, I will share the instructions, send it to you. But you know, the same idea, how you shoot the ball to a random direction, we will go over it next class. Oh, it's on the course website anyway. Yeah, it will be on the instruction. We can go over it next class. Cool. See ya.